Hello everybody and welcome back to part 3 of the Monaco PCB repair. Boy, has it been a day. Has it been a day. We are still with Crazy Blue, but I had to fix another problem on this thing. While I was working today, I had this thing running basically all day. And which is a good run test for it, but I had a failure on this board, and it was another one of them socketed 157s that went bad. And the symptom was I didn't have my camera out here, or I would have filmed it. The thing that happened was, you know how the road does this, it goes in and out? This top would wrap all the way around and come back to here. So it's like this top would sit here and do this, and then it'd wrap all the way around the screen and come back. So, yeah, it was a bad 157 on that board. Yeah, interesting. So we're back to just Crazy Blue. And I have been all day with the little scope going over this page. And I've spent all day doing everything I can do with the 4 inputs on the little scope. So all the 157s, if they were always enabled, you can do 157s with 4 inputs. Obviously all of the 2, 3 input logic gates, 2 or 3 input logic gates, and there's a lot of them on here. The 74s, as long as the clear and presets are pulled high, which most of them are. This one wasn't, but I was able to do this one anyway because the preset was floating, actually. I don't like how they designed this. They leave a lot of inputs floating, and I really don't like that. They did that on a lot of old equipment. Instead of pulling something high, they would just leave it floating. So I went through all of what I could do on here basically and got to where now it's 161s, but I don't believe this is a 161 problem. 161s are used to pick off addressing, and this section here, this page, the 161s are used to pick off addressing for this ROM right here, which holds all of the data for the cars on the screen. Okay, I believe it's the opponent cars on the screen. All of the data is right in here. Yeah, so and that's fine. So I don't believe it has anything to do with these 161s. If we kind of logically look at what's going on with the opponent cars, they kind of do this. They go, and then Crazy Blue just goes, you know, see him? So they kind of move up and down a little bit. So I'm kind of thinking there's a lot of 193s on another page, and 193 is an up-down counter. And I believe that this page right here is where the problem is going to be. I believe this is opponent car control right here, this page. I believe that this page that we were looking at is opponent car picture data. And this is the actual positioning of the opponent cars, I believe, this page. So I want to starting tomorrow, I want to focus on this page right here. And there's an awful lot of 193s. There's 1, 2, 3, 4. There's 4 193s which are up-down counters, and then there's these 85s, and 85 is a, what is an 85? What exactly is an 85? Let's get the old big TTL book And let's look up 85s. Okay. An 85 is not a simple chip. It's a quad 2. Oh, that's an 86. 4-bit magnitude comparator. Comparison of two n-bit words. So it compares two words. This application demonstrates how the magnitude comparator can be cascaded. No, I don't care about that. I want to know. Just give me a description of the chip. Okay, description, magnitude comparator. These 4-bit magnitude comparators can preform comparison of straight binary and straight binary coded decimal codes. Three fully coded decisions about two 4-bit words A and B are made and externally available at 3 outputs. These devices are fully expandable. The A is greater than B, A is less than B, and A is equal to B outputs. Okay, this is simple. This is a simple chip. I can absolutely I can analyze those 85s, no problem. LS85, LS85. What's the difference? Oh, that's the military one, I guess. This is the one I'm looking at. B3. Okay, these must be the inputs. A0, A1, A2, and A3. There's a 4-bit input. And then you have, B0, B1, B2, B3. So you have 2 4-bit words. And then it just compares them in out. Yeah, I'm going to have to read more on this. Here's truth tables right here, function tables. So I'll have to really understand those chips, kind of read this whole page and get to understanding them. And it should be easy to look at. But I want to look at all of these chips. I want to focus on this page and find Crazy Blue on here. This Crazy Blue is on here somewhere. I'm sure of it. Yeah, we'll get you, Crazy Blue. I will get you. I'm coming for you, Crazy Blue. There he is. There he is. Crazy Blue. By the way, take a look at this. One of Michigan's treasures right here. Faygo Soda Pop. This is firework. It's basically like a bomb pop, or whatever those things are called. Bomb pop flavored soda. Yeehaw. Well, just a status update on this guy. I did find one thing, but it does not pertain to our Crazy Blue problem. We still got Crazy Blue going nuts over here. What I did find was there was a near short between 5 volts and ground on this board. So I removed all of these tantalum caps that were here, and it went from doing diode check, it went from red lead to ground and black lead to the positive. I went from about 0.014 of a reading to 0.25 something of a reading. So it really, one of those tantalums was darn shorted. So Yeah, that's a lot better that way. It's obviously going to use a lot less power that way if you've got more higher resistance between the rail and ground, you know, the 5-volt rail and ground. So I'll replace all that stuff later, but we're still looking for Crazy Blue. I've analyzed all of the 393s. There are up down 193 counters on this board, but they're not really doing anything. There's no real inputs to them at all. So I'm in the process of looking over the schematic on the 193s and find out how come there's no up down counting going on. What is the deal with that? And how does it pertain to Crazy Blue? Where is that circuitry? I'm having a hard time pinning that down. But I'm just going through and I'm continuing to analyze. All the 161s are perfectly fine. The 393s are all perfectly fine. As far as I can see, the 193s are all perfectly fine. Is the problem on this board? You know, I don't know. I mean, kind of strange. A strange issue here with the Crazy Blue. All right, well, I will continue to look. All right, I told you a while back I have 3 Monaco GP sets. And this is the one I've been working on. This is the one with Crazy Blue. And this is the one, this is the other board that goes along with Crazy Blue. Okay? And then there's this set that goes along with that one right there. And then there's Super Monaco over there. You know, 2 of them are regular Monaco GP, 1 of them is Super Monaco GP. I put this one on here. This one has graphics issues. That board right there just has color issues. This one has a graphics issue. As you can see, the cars are goofy looking. But Crazy Blue acts perfectly normal on this board. That's Crazy Blue right there. I don't know if you'll be able to see him. He's the one that moves the most. There he is. Crazy Blue. There he goes. There he goes. See, he acts perfectly normal on this board. Now, this board I've been probing around. I decided to, I was like, you know what? I'm taking a break from this one. I'm going to start looking at this one. Since Crazy Blue works perfectly fine on this one, let's fix this graphics issue on this one. We'll get 2 birds stoned at once, or something like that. I've been probing around and I came to this. This is a 08. Input. Come on. You got to get through the crust. Input and output. Floating. Input. Output. Floating. Input, output, floating. And you guessed it, input, output. Guess what? Floating. That's a 08 that's completely dead. And then here's a 393, and a 393 has a clock, which it's not moving, it's not clocking anything. It's got a clear, it's not cleared. And here's the output bits. Here's one of them. This is the least significant. Here's the second bit. Here's the third bit. And the, wait, I got that wrong. Alright. Clock, clear. So this thing is cleared. This is clear high. So our output bits, I'm sorry, that's a 193. I was like, what's going on here? It's a 193. All right, well, that's a little different. Clear is actually on pin 14 on this. It's not cleared. Up count and down count. This thing is not counting right now. But if I look at the output bits, here's the least significant. And the second bit. The third bit is floating. That's the third bit. And here's the fourth bit. The fourth bit is high. So that bit right there is dead. It's just floating. So that is definitely a bad 193. So we got a 193 and a 08 that I have noticed just probing around that those two are dead. So I think what I'll do is I'll clean this board up. I'll recap it and replace those two parts and see what we get. This board needs to be washed though, so I'm going to go ahead and do that. Replace all the electrolytics. This one I checked the voltage between positive and negative, and this one none of these are shorted, so this one looks good. So I'm going to go ahead and clean this one up and replace those two parts. Let's see what we get. I'm looking at these LS85 4-bit magnitude comparator chips, and check this out. My road is being torn up because they're putting new water lines in. The neighbors hanging out. But yeah, look at that. There's a big old backhoe or whatever that is. Dust and dirt everywhere. Yeah, interesting. I don't want those dudes to think I'm filming them or whatever. It's all good. Alright, let's come back in here and look at these 4-bit magnitude comparators. I actually put a different set. That set that I replaced I washed this set and replaced all the caps. The 08 that was bad, the 193 that was bad. This is that board set. It's the complete board set. I put this board on there as well. But I'm going through this one, trying to get this one right, and you'll see it's pretty much fixed except for Crazy Blue, which is right there. He moves fine, but he looks goofy. See that? Check him out. He's like doubled up or something. So I'm just going over these 85s, and I've been poking around and I don't really see much obviously wrong. But I wanted to get some experience with analyzing these 85s, and I've got the TTL book out and the truth table, the function table of the 85s, and it's a bunch of A less than and greater than B inputs and all of that, and basically how it boils down is you have the two inputs A and B. Okay, you have A and B inputs, and then you have, and this thing will look at those and determine which is greater than which, and we'll spit out the outputs here on 5, 6, and 7 based on that. And if A and B are equal, A0, B0 through A3 and B3, if those are all equal, then it kind of bases the outputs based on these inputs here. The A is greater than B input, A is equal to, and A is less than B inputs will determine the outputs. It's a little complicated, but not really. It's pretty simple. Once you have it set up on your analyzer like this, you'll see I have B3A3, B2A2, B1A1, B0A0. And that's how they're actually arranged now. This 2-bit word here. This is A0 and B0. A0 being the 1, B0 being the 0. And then here's B1A1, those inputs, 2-bit inputs, set to binary. And then you have the A over B, which is A greater than B, or B over A, which is A's less than B. And this is my symbol for A is equal to B. And then you got your outputs. A is greater than B out. B is greater than A out, and A is equal to B out. Okay. So if we look at our signals here, these inputs, we have equal to, and check this out. If A3 is equal to B3, then you move on to the 2's. And you have two possibilities. Either A is greater than B or A is less than B. If it's equal, you move on to the next. You move on to A1 and B1. And then you got two possibilities. If A1 is greater than B1, then you have a set output. If A1 is less than B1, then you have a set output over here. But if A1 is equal to B1, then you move on to the 0 set. And if all 4 sets are equal, A1 equal to B1, A0 equal to B0, and so forth and so on, if they're all equal, then you move on to the inputs. They'll determine the output. See, they don't matter until everything is equal. So if you see something that's not equal, you can stop right there and consult this. But if you see that they're all equal, then you got to look at the inputs to determine your outputs. So here we have 0, 0, that's equal. 0, 0, 0, 0, 0, 1 is not equal. We have 1 greater than A. Or we have A greater than B. This is A, remember. The 1 is A. The 0 is B. I got it, A, B. A's on the right, B on the left. So A is greater than B. So let's see what our output should be. If A is greater than B, and that's the zeros, A0 and B0, that's this column, and A was greater than B, so that's this one right here. So we move over, our output should be high, low, low. That should be our outputs. So let's move up. And right here where we had A being greater, this is A being greater than 1. Let's just kind of, let's move this over just a little bit. Okay. Now we have A greater than 1, or A greater than B. So we come down, remember it was high, low, low. We have, here's our output, high, low, low. And here we can see it goes from that to low, low, high. Now let's see exactly why does it go low, low, high at this next thing. Okay. Come on. What's going on here? There we go. Right here, remember, okay, here's another equal. Let's just scroll it over. Get that out of the way. We have another equal, remember, equal, 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 so we move on to our inputs, which are 1, 1, 1. If they're all equal, our inputs will determine the output, and they're all ones. So we come back over here, and here's LS85. That's what we're looking at. And if they're all equal, 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 and all of our inputs were high, remember, all of these guys are high, 1, 1, 1. Those are our inputs. They're all high. And actually, if this one right here is high, our A equals B input is high, which it is, then these don't even matter. We don't care. Our output is low, low, high. Low, low, high is the output. So if we scroll down, for that little time frame right here, we have low, low, high. See that? Low, low, high. 0, 0, 1. Right where all of them are equal. And then it goes back to 0, 1, 0, which is because we have equal to, and now we have A being less than B right there. Equal, equal. Now right here, A is less than B. And one thing about these, if A is ever less than B, this is what's easy about these. If A is ever less than B on any one of these four scenarios, the output will always be 0, 1, 0. 0, 1, 0. See, it's 0, 1, 0 the whole time. That means that A must always be less than B somewhere. A is less than B, A is less than B. This whole time A is less than B. This one, it says A is greater than B, but it doesn't matter because we don't get to that one because A is less than B up here. So this, anything after this doesn't matter. You go from, it goes from 3 down to 0, remember, on the truth table. You start at 3, and if A is greater than B or A is less than B, we don't care about anything else on these lines. Only do we move forward when A is equal to B. So yeah, I've been going through and checking these 85s. Just wanted to do a little bit of documentation on how they work, and man, that stuff is loud out there. Anyway, yeah. I'm going to continue on with these and I'll report back. So far so good with the 85s though. Okay, well, I did find something that does not look right on this one right here. This is IC 113, which is this guy. It's one of those 85s. And it's in this circuitry, irregular, car control, irregular. Is that crazy blue? Car control? Car something or other? I don't know. Anyway, if we look at that, I can tell right now that here we have equal to, equal to, equal to, equal to for this whole section right here. We have equal to. So if we have equal to, our outputs are determined by the inputs. And we have 0, 0, 1 on the inputs. Okay. Now if we have 0, 0, 1 on the inputs on an LS85, it's this top line. We don't, if this one is a high, we don't care about these two. Our outputs should be low, low, high for that whole duration. It should be low, low, high. for this period right here, where you see this 1 1, we should have low low high, and we have low high low. You see that? Low high low. That should be, what did I say? Low low high. It should be low low high. It should be 0 0 1, and it's not. That's definitely not working correctly. And then for this whole duration right here, where we have 1 0, that's going to be the 0 1 0 output. And then we pick up, we're going to have a little bit of a spike of 0 0 0 and whatever this is. It's hard to go zoom any faster than this though. So we have equal to 0 0 1, so we should have 0 0 1 on the output. And we have 1 1 0. It's kind of opposite of what we should have. But that could be a delay from this right here being, I don't know. This thing's not working right. That's the bottom line. I don't like zooming any further than 50 nanoseconds. It's kind of a threshold with these parts. Let's take another screenshot I just took of it. And we have zeros, 0 0 0. So this is determined by our inputs once again. This whole time right here on the edge, equal to, so 0 0 1. Our outputs down here should be 0 0 1. And if we check it out, it is 0 1 0. This one's not working. This guy right here doesn't work. This 85. It looks like it works based on the inputs up here. But when it gets determined, when these are all equal and the output needs to be determined by these inputs, it doesn't work. Like right here, it's zeros, and right here it'll go to 0 1 0, or it never left 0 1 0. See? And then we get a little spike right here because I don't know why, because, to be honest. Because why? Yeah, I don't know. This one just doesn't work. So we got definitely one bad part right here. So I'll replace that guy and move on. I'm actually going to look for any other 85s. I'm just going to mark that one red. It needs to be replaced. And see if there's any others on here. Okay. I replaced the 85. Here's the old one. And I just removed this and I put it in my TL8662 Logic, my that tester. I really like that thing for testing ICs rather than using that. And yeah, this thing is very bad. In almost all configurations of testing, it fails. So this one was bad. New one in, it's running, and it's the exact same thing. Crazy Blue still looks wrong. Where are you? There he goes. Why is it all fuzzy? What's going on? Hold on a sec, I'll be right back. Wait, here it comes. Okay, we're focused. Alright. Where are you at, Crazy Blue? There he went. No. There he goes. There he goes. He still looks goofy. There he goes. Yeah, he still looks the same. I mean, that was a problem. I don't know what I don't know what kind of a problem, but it was definitely a problem. I don't know. Bad chip. Weirdness with these boards, man. I tested all of the 85s other than, here's 85, 85, 85, 85, and then there's 4 up here I did not test. So I'll test these 4. There's one right here as well, but it's got a wire soldered to it. So if I want to test that one, which I do, why not? I'm going to have to relocate this wire. Probably to the bottom of the board. That wire right there. And these are 192s right here. And that's all of the 85s. And that will be all of them tested and verified, eliminated from my issues. Now this one, I'd love to know what this one actually does. I'll get the schematic back down and check it out. It was something to do with, I don't know. I don't remember. So I'll check that out. Try to understand what that failure would do, because it doesn't seem to do anything. Maybe it's a gameplay thing. I don't know. You know, either way, regardless, it was no good. This chip is no good. So this one is good. So I think with that, I'll go ahead and dump all of this video information and upload another part. We are still looking for crazy blue issues. Now this board does have a color issue. I'm not too concerned with that right now. I want to get these boards right. This one, crazy blue, acts good but looks goofy. The other one, he looks good but acts goofy. So go figure. And I believe the other board, this one, I believe that board is good to go. But this one does have an issue. So we're getting there. We're fixing stuff slowly but surely. I'm eliminating stuff as problems, and I'm finding problems that just don't make no difference. That don't make no difference. How's that for English? But yeah, let me go ahead and upload this one. And stay tuned. We're going to keep hunting. Hopefully we can get these things 100%. They're so close. We'll get there. Stay tuned. Shout out to all Patreon members. Thank you all. Your continued support helps me continue to do this and upload these videos. Thank you.